Thank you. Great, that's changing now. So we're going to talk about a couple of things today. Before, I just wanted to ask a couple of questions so I have an idea of how to target content. Who here has actually written an Ember application before? About 3. Great. So a lot of the stuff I'm talking about today I've made sure isn't Ember specific. I'm very glad I did that now. And just hands up in general, who's written some type of framework-driven JavaScript application before? Okay, great. So I'd always just ask those questions so I know how deep to go with content. Before we get started, though, I always just introduce myself and what we do. So, as was mentioned in the intro, I mostly write Ember at this point. I've been on Ember for about 3 years now, and we focus on building hybrid mobile apps with Ember that will match native performance. That's actually completely possible. If you go to our blog, you'll see a lot of the stuff we talk about how to do that. A lot of it's just understanding how memory works in that context, and we're going to go a little bit into that today. Before that, I wrote a lot of Rails, a lot of Go, and like everybody, I think I started with Java and C. This will be the only plug before we go to real content. Again, it was kind of mentioned in the preamble. It says Toronto and Chicago. Our Houston team only opened up about 4 weeks ago. I actually got brutally sick while I was down there and only just recovered. We focus on building these Ember hybrid applications as a shop, about a 50-50 mix between YC companies and much larger enterprises. So in terms of what we're going to cover today, after a little bit of a preamble, just with knowledge I think is required for the topic, we're going to talk about using a single Ember app and then rendering it for desktop and mobile in the browser, then also reusing it for a native mobile application and also reusing it for native desktop application. Again, I'm going to say the word Ember a lot and give you a bit of a crash course, but everything I'm talking about you can use completely outside of Ember. So one of the reasons we're attracted to this, and I think this is immediately obvious to everybody in the room, is so that we can actually just have one code base that manages everything. I'm going to go into some of the drawbacks of that as well, but ideally by the time we're done today, we understand how we're going to do this without polluting the code base or leaving it at a point that it's running very slowly or getting to a point that it's not maintainable by any programmers. Just to start, I realize audio's been dead for months, but I still refuse to admit that it's gone, so I still use my audio screenshot everywhere. But if you weren't familiar, audio was actually a hybrid application, as is Spotify, as is your PlayStation, Xbox interfaces. So just pointing out that this is something that's already happening. What I'm talking about isn't something that if you do really, really well, you might be the first company to pull off. This is all over the place. So a couple of tools that I'm going to talk about, and again, I'm only introducing them because if you haven't written Ember, you wouldn't know what these do. And I bring these up so that you can figure out what the analogy is to whatever programming environment you're working inside of. So Ember Cordover is actually my pet project. I spend most of my programming time on it. And it's the main Cordova bindings for building an Ember application. So it actually jacks into your Ember application, will generate a Cordova app, can pull the right templates if you've separated your templates out, will handle things like managing your splash screen icon and actual device interactions as well. In a lot of ways, we're trying to mimic what Ionic has done for Angular and start pulling something like that into the Ember community. Just while we're talking about hybrid as well, because once we've gone through all of the CSS stuff I'm going to talk about today, you could easily just install Ember Cordova in your application and spit out an actual iOS app and an actual Android app. Just understand that while something might work really, really well in desktop Chrome, hybrid apps are much more penalizing for bad code. So just understand that you really want to keep the best standards at every moment. It's not really in the scope of the talk, but if you're not sure what I'm talking about, go and Google things like detached DOM nodes and how to recognize memory leaks in JS. Very, very simple stuff once you understand what it is, and it will let you write much more performant applications. I'm going to go into how that impacts as well. Last thing I'm going to talk about in the hybrid thing is the WK Web View. If you're not familiar, all Cordova does is it spits out a website inside a native application, which is why you can take this J application and reship it, right? It really is just a website that's become a mobile application. I tell a small lie. Last point on hybrid is now. So when you're building Cordova apps, sometimes you have event listeners, right? You might be listening for a click, you might be listening for something to load to go in and put different style sheets, whatever it is you want to do. You see people doing these gigantic hacks inside of Cordova because they're worried that the website will initialize before Cordova has finished initializing, and that does happen. So they don't want to use this device-ready hook because they're worried that it will fire before the rest of the app is ready. Or they're worried that your actual JS will start executing once Cordova's finished loading, and again, this device-ready hook won't fire. I just wanted to point out that device-ready is actually a special case listener in Cordova. So if device-ready is already fired, once you drop a listener for device-ready, it will fire immediately. So you don't need to worry about this case where it won't actually shoot off. Second library we're going to be talking about a bit today is called Smoke and Mirrors. It's also written by Chris, who is from I Love Code. And Smoke and Mirrors is an occlusion-based infinite scroll. So you're going to end up, as we're building whatever it is to work on a tablet or a phone, we're going to want some type of infinite scroll in the app most probably. And I have a sample app we're going to go through today that uses something like this. Smoke and Mirrors does an occlusion-based infinite scroll, and what we mean by that is it doesn't create a new DOM element for everything that will be in the list. It doesn't delete elements that are in the list. Instead, it actually recycles elements. So you don't have to go through this expensive pull down, tear down, and redraw process every time we're scrolling. It's blazingly efficient. Last thing I'm going to talk about is also written by Chris Avile, and it's Flexi. And that's going to be how we actually achieve this cross-platform build that I'm talking about. So getting into real content, responsive versus fluid was just something that was mentioned in the talk description. I don't want to go too deep into it because I feel like it may have been covered a lot already today. But responsive in our world really just describes using media queries and breakpoints, whatever else, to resize content around the size of the browser, right? We recognize that layout has changed and we start doing something as a result. Fluid, on the other hand, in our world describes something that will snap to its container size. So we'll actually go and fill whatever container it's being put inside of. These aren't mutually exclusive concepts. In fact, you're going to find we're using them both together to achieve something that will work everywhere. So this comes from a blog that was, again, written by Chris. This is the last bit of Chris content that we plugged today. But I wanted to give an analogy for those people who have only used Bootstrap before to try and get an idea of what's going on. So we have a few different terms that I'm going to keep bringing up here. So the Bootstrap colmd push and colmd pull are examples of reflow design, because they're basically going and changing spacing, sizing, whatever else as a result of the window. Down here, I'm not going to read these whole points. Reorder is very similar, but it's using flex and the order or position number if you're familiar with that property. If not, just go and look at the flex spec. These are very, very similar. Again, this will all make sense soon. So we also need to manage our reflows very tightly. Does anybody here know what reflow is? Okay. So Reflow is one of the most expensive things that your application is going to do, be that on desktop, be that in hybrid, be that on mobile web. And Reflow is basically when the browser has to go through and recompute what's on the page, where is it, what color is it, what styles have I applied, etc. And what's important to note here is that it's not just happening on the node you've changed. If you change a div, it's highly likely that that entire DOM tree or your entire DOM tree is actually going to go through a reflow, and that's because you have classes that target parents and children. So it's actually very, very hard for the browser to predict what's changed, so it just goes and repaints basically everything. If you're familiar with having jank in animations, if you're familiar with having AJAX requests blocked and not going out, if you've been building a hybrid app and as you're resizing the screen, it's this like weird blur and jittery stuff that happens all over the place. That's basically reflow going on. Reflow is also completely blocking, so while this is happening, your JavaScript application isn't doing anything else. So it's really important to understand what reflow is. And if you're curious about what causes a reflow, there's a couple of things. One of them is just resizing the browser window. And that's what's very pertinent to what we're talking about today, because we're going to talk about taking a desktop app, and as we pull the Chrome window down, we're going to start rendering the mobile template more and more. Anything you do with a JavaScript method that involves changing a style is also going to handle or cause a reflow. Anytime we add or remove an element from a DOM, we're also going to trigger a reflow. This is why that smoke and mirrors occlusion-based scroll starts to make a bit more sense once we understand reflow, because every time we add a new element, we're not actually going through and triggering the entire DOM to need to update. And obviously changing an element's classes as well. I have a link down here if you're just interested in learning a bit more about what that does, because I realize I'm going incredibly quickly with this right now. And if you're interested to see kind of what CSS properties do and don't lead to reflow, just go to this website here. I'll put all of these slides online so you don't need to write it down. That will give you an idea of what CSS properties contribute to reflow, which ones don't, and in which contexts this will happen. So if you want to avoid reflow, the best rule I can give you is to use your CSS transforms as well. If you're not familiar, if you want to move an element across a screen with pure CSS, you have a couple of different choices. The first one, and this is the most naive implementation, would be to say maybe have position absolute, top 0, left 0, and then a second later, top 10, left 10, and start animating the square. Problem here is we know that changing a class or an element's attribute is going to reflow. So that's actually a very expensive animation that we're moving across the screen. If instead you use your CSS transforms, that's your translate X, your translate Y, these are actually special hardware accelerated properties that won't trigger a reflow. So if you need to animate an element across the screen, the golden rule is to make sure you're using your translate X, translate Y. Another really good example here that trips people up is if you're trying to hide something from the screen. A lot of the time you'll see people do display none, and we think we've just done a really good thing because we've just taken something off the screen and it's not being rendered anymore. Because it still sits in the DOM tree, both changing that style is going to contribute to reflow, and every time we're reflowing, that entire node we've hidden is actually still adding to the cost. If instead you use visibility hidden, which does render a little bit differently, again, visibility hidden is a special case that won't cause a reflow anywhere. Last interesting point on this, I don't have a slide for it, I just want to bring up while I'm chatting, which is where you see people also have expensive reflows. If you ever to a jQuery variable or a JavaScript variable, or something like that, so it's referencing a DOM chunk, right? You might get a selector for a div called ID or something like that. If once you're done, you don't actually go through and do that selector equals null, you've actually still maintained a reference to that DOM element. And as much as it might not even be rendered in the canvas anymore, that's still eating Chrome memory until you actually hard refresh Chrome now. That's what we start calling a detached DOM fragment. It's going to sit in memory forever. You no longer have capability to remove that anymore. And this is when your app starts to become choppy. In fact, a lot of the times we see, say, mobile implementations of a desktop site, this is one of the things that they get wrong immediately. They have these variables referencing desktop elements that have now been removed from the page. Because that variable still exists, they now have 30 megs of memory that are sitting there that can never be recovered again. So last point before we go into an example app here, this isn't something that would ever hit my world, but given a lot of people here seem to not use frameworks, we hear a lot of advice to try and have as few style sheets as possible, as few images as possible, as few different assets we need to load by a HTTP request as possible. If for whatever reason you're in this scenario where you need to put 7 different spreadsheets in your template, but you know at the time that you're building it that only 1 will be used or that only 2 will be used, know that you can add this disabled tag to your style sheet link. And doing that, the browser won't make any attempt to request that style sheet, it won't make any attempt to load that style sheet. I generally encourage you that this is a bad practice, and if you find that you need to be using this, maybe consider going to a framework or structuring your code differently. But there are some cases where just the hacky approach is the best approach. This usually changes for me around 2:30 in the morning when I just want to be done and go to bed. You'll see me pull shit like this all the time. So getting into an example app, and we're going to go to the fun part of the content now, which is how do we take a single application and figure out how to make this work all over the place. So I needed to create a fake application. I was going to build a whole app, but I just have code fragments and wireframes for you today because I was a little bit sick. But I decided to make an app called TouchBase. So what it does is you'll see on the desktop version, we have a menu to the left. We have an array of contacts that are clearly being rendered in some middle pane. And on the right, we have a selected person, and it shows when I last touched base with them, and I can press a button to touch base with them as well. So the business people are going to love this shit, right? And we go to look at the mobile template, and it's very, very similar. The only difference is we have our menu up the top instead of to the left. It's rendering a little bit differently in a different order. Contact array basically looks the same, and we don't have that pane to the right anymore. Presumably by touching that, it's going to pop a modal, maybe expand, but something will happen to render that screen. So looking at these two, we're going to look at this and figure out what's the most efficient way we can write this in a single code base. So only because you're going to see a couple of Ember snippets, it's important to understand how Ember would view this. Ember is routing driven or routing driven, depending on how you like to pronounce your words. So we have a contacts route and then a singular contact route. In Ember, not one single route is active at any given time. You can actually have multiple routes active, especially in a nesting scenario, which is why you see this contacts contact there. That's just a little bit of Ember logic. You don't really need to understand it. You're just going to see it a lot throughout these examples. And this is what our actual directory structure would look like. So I tend to structure my app in pods, which means the controller, the route, and the template actually all live together in a single folder versus living each in a controller's routes and templates folder respectively. If you have the capability to do this when you're writing code, it can feel a little bit awkward at first because you feel like all controllers should go in a controllers folder example. But what you start to find is when you're working on a sufficiently large application, and most apps we work on tend to become pretty big, it's easy to start thinking about the app in terms of pieces of functionality. And as a programmer, you're generally only working on one piece of functionality at a given time. So it's actually much easier to have everything bundled together where you can start to find it and not have this huge tree or need to keep looking up different files. Ember lets you do both. You could alternatively just have your controllers in roots folder as well. One thing we do immediately is we always actually put the styles in the pod as well. So as much as we have a global application CSS file, we can actually go and put a styles.css in every pod and put styles that only relate to this pod or this feature inside of that. That actually won't result in hundreds or thousands of different CSS files. Ember will concatenate all of these to our app CSS at the end of the day for us. It's just an easy way for you as a programmer to manage what's going on and to get to a point where each file is small and bite-sized. Because one of the things we always have to consider is we're hiring new people all the time, our clients are hiring new people all the time. I don't want to have to explain for the 10th time how something works or why it's structured like it is. Seems good now. No?
It's us.
It's you?
It's us. I don't think it has anything to do with you.
I think we're safe. Yeah, it is. That's actually what a reflow would look like. So this is a pretty light slide anyway. While you fix it, I'll just go with this one. So the last point I'm going to make, and then we're going to start actually structuring CSS and templates here, is when you're registering taps, right? Because we want to go on mobile, which means we want a natural mobile experience. For those that aren't familiar, on mobile, you're still actually firing click events, and they have a several 100-millisecond delay. That's why sometimes when you go and visit somebody's mobile website, you press a button or you tap a button, and it feels like it's just that half tick too slow. It's because they've actually registered a click event. So we want to convert all of those to taps in a mobile environment. Two things to keep in mind there. I'm going to show you how to register those on the next screen. But for this one, just understand that your tap targets, you generally want them to be at least 48 pixels on a mobile device. You'd find this is recommended by Chrome and several other engineering teams, and it's just the level at which it's not too small for somebody to find and to accidentally click something else. So we also tend to use this library called Hammer.js. Has anybody heard of Hammer.js before? Great, a couple. So within Hammer, what you can actually do is start registering what events your component is going to respond to. So, well, it's not clicking anymore. So you'll see we go and enable gestures on a component here. If you're not familiar when I keep saying component, what I'm describing is a template, a piece of HTML, and a piece of JavaScript that's bundled with that, which is a piece of functionality. So a submit button would be a component, for example, as would that entire contacts list. So components can both be incredibly broad and very singular, and you'd often find that one component will implement several other components. So in this component, we're just saying that it's going to register a tap event, which is a single tap. We're saying that if somebody holds for 800 milliseconds, and we're actually going to fire a hold event, and a pan, which is just somebody moving their finger across the screen. So the threshold 3 is just how much they need to go and move that finger. And you'll see, we've programmed some constant at the top of this file that's just, which direction we want that pan to go in. Then you'll see we just add the listeners, and then down here, we're just basically registering, nothing different to a normal event listener that's going to fire when those events go through. In a later slide, I'm going to show how we implement this only on a mobile website. For now, let's just pretend this is completely generic. And if you haven't noticed, just a quick little Easter egg here, I have a transparent terminal, and I didn't realize that I was actually throwing a really bad error when I took this screenshot, which is showing up right below there. So going back to our touching base app, if we start to reason about it, the first thing we realize is that contacts array is basically the same on both. It looks to be an example of that fluid thing that I'd mentioned before, right? It looks like it's sizing to the size of the container it's in, but it's otherwise acting exactly the same as it was before. And if we look at the mobile navigation, it's definitely in a different spot, and it seems to be ordering items, I always mix these up, vertically versus horizontally. You'd hope I knew that by now. But otherwise, it looks to still be doing exactly the same thing. So if we start to consider that, we realize that our components are actually the same. So this is hint 1 in terms of how we're going to build this app. So we can reuse the same logic, we can use the same roots, we can even reuse the same JavaScript. It's just that the actual templates of these might be slightly different. So the first thing we start considering is, should we use media queries? I'm sure you all know what media queries are by now. Media queries again. So when we get started with media queries, I find that there are some questions that just everybody asks as we're starting to implement these. And the first one is, does the number of different CSS files you have matter? And perhaps related to that is, should we do this inline versus separate? And what we're describing there is, if I have a series of media queries specific to desktop, is it best practice to put them inside of a single app CSS, or is it best practice to split them out into a desktop file and do something with that later? The answer is, in general, the more assets you're loading, that's actually penalizing you on boot, so you don't want that to have happening. But once you've actually loaded the site, the amount of CSS files you have doesn't matter. The best thing you can do if you're not inside an Ember is to find something that will actually serve as an asset pipeline for you that will let you have several different CSS files and will concatenate them to a single one at the time you're building your application. So then you can have the best of both worlds, right? Your program is happy, can go and find things very quickly, and it's well named. By the time we're actually sending that down to a browser, which really doesn't care how things are named, it's actually easy for it to pass and execute. The other question that comes up all the time as well is, does the number of media queries matter? Right? Should I try and have one single media query per size, or should I have one for each different case? The answer is that the performance difference is quite negligible. Where this will actually impact you is when you're going through one of those reflow scenarios, because the amount of different rules you have to recompute is just becoming exponentially more expensive. That being said, the performance difference is so negligible that I wouldn't get to a point where I'm flattening media queries that make sense to be separate just for the purpose of making it more performant. That's a sign that, again, we're just maybe approaching our build from the wrong direction, but it's something to keep in mind as well. If you're interested in just seeing what the performance differences are, there's this link on GitHub run by a guy named Aaron Jensen that will actually run different media queries, different amounts of media queries, and let you see what the performance difference was. So if we're to implement media queries with this, I didn't do any CSS examples for this because I felt like at this point you probably all know what media queries are and you've been beaten to with them all day. But there are some problems with this approach immediately. The first one is that our reflows are actually going to be quite expensive, because we're having to go and recompute every time we resize the page, and we have a bunch of different rules that may or may not be applying. In my opinion, and this is just my opinion, the code also gets really confusing and hard to follow very quickly. Because now all of a sudden I'm looking at a template and I'm trying to understand, does this change when somebody's in mobile versus when they're in desktop? And I actually can't tell by looking at the template. So I have to go and look at a CSS file. And depending on how you've structured your app, that could be in several different ones. I actually have one client who has, I think, 7 different CSS files. I've just copy-pasted from different apps to the point that the same rule lives in 7 different places now. So it gets really confusing and very spaghetti-ish very quickly. And with media queries, we can't do much complex, right? We can kind of change the structure of a page that we already have, but we can't go and completely change what's going on because it's mobile, but still use the same single components. So the next thing I see people attempt is something like this, and I've described 2 different techniques on this slide here. Maybe what they do is we instead have a desktop and mobile, and we go and implement the same divs, right? We have navs, contact, and contact pane, and for mobile we just have nav and contacts list. And either what we're doing is we're display nunning that left pane, that when I say contacts pane, I just mean that contact that was being shown on the desktop to the right here, that selected person. And we might either display none the entire mobile layout until we pass some breakpoint at which we start displaying it block or whatever we want to do. Or we might just display none that one piece that we know isn't showing up and otherwise hope for the best. This actually faces the same problems, though. And where it actually faces the same problems is twofold. Your reflow has actually become more expensive now, because in mobile we have this entire contacts pane that's actually not being rendered in this context, but it's still sitting there in the DOM, right? As much as we've displayed none it, as I was explaining earlier, in any reflow scenario, that's still going to penalize you. So you actually have this big meaty piece of stuff that's just sitting there doing absolutely nothing. It's starting to drain your performance more and more. So this is what I see people attempt next. So we have our nav. You'll see now I've just started adding conditional classes based on whether we're in mobile or not. Just imagine this Boolean works. This Boolean would work in Ember for you. Then we have some type of Boolean or variable here that's if is desktop, render the contact pane. So in this case, if we're in a mobile environment, that entire div isn't going to show up anymore. So we start feeling like we've done something better. And in a lot of ways we have. In a mobile context, we're not being penalized as much. But in the cases where somebody's resizing their browser window, we've replaced a series of medium expense operations with one very high expense operation, which would be reevaluating this block and inserting this template once we pass a breakpoint. The other problem with this approach, though, is that your code is still no more maintainable than it was before. Because there's actually no declarative way to see what's going on in mobile or to see what's going on in desktop, right? The best you could do is grep if is desktop, presumably there's an if is mobile as well. That might be happening in templates, that might be happening in components, that might be happening in styles. So we're still just as confused as we were before, just maybe with something that has less lines of code. So as I was saying, that's still very hard to maintain. Canonically, we don't know where to go and find what's mobile and what's not mobile. Our components either need classes or our containers, and we need to start, dealing with problems there. And we've just introduced a whole ton of complexity to our code base. Imagine we weren't dealing with a single root here, but a real application that had 20 or 30 of them. Now to actually go and find the ramifications of making a single mobile change could be happening in 30 different places or 40 different places. Even if it's a good programmer who keeps this only to CSS or only to a template, we still can't actually predict where something would change. And as a programmer, one of the most important things is being able to look at a code base and predict what it's going to do. That's a sign of a good piece of code. A bad piece of code is when I go and change something and something completely different happens in a completely different section. So to summarize where we are right now, we know we have this fluid thing, but that really only works, and this is taken from the blog I mentioned earlier, by the way. Fluid only understands the boundaries that it's inside of, but it has no broader understanding of its environment. We have reveal, which is that showing something that was hidden, right? That display none to display block. But that slows down renderings of the DOM tree even when that's not present. We have reflow and reorder, but they keep causing expensive reflows and repaints, so we don't want that problem either. We see that these are all kind of hard to reason about. Restructuring is just as messy. Restructuring is having that if-is-desktop block in JavaScript and not handling it from CSS. And we have layout CSS that we can't even reason about, right? We're looking at these different media queries. We can't actually look at this and visualize what's going on. What's interesting, though, is if we start taking a step back and looking at this application, we notice that the components are actually pretty similar, right? We don't even need to reason about how the components are different. It's actually layout that's changing. And if we have fluid components, it's only layout that we need to worry about when we're changing environments. So again, just looking at this, if we take away layout, we realize that those contact lists are exactly the same. And those two menus, apart from a slight rendering change, are exactly the same. So we're going to start looking at, okay, well, if we could just worry about layout, can we resolve this problem? So this is really the approach we take when we're building cross-platform, which is that layouts change and components are fluid. We'll actually write a completely separate layout for each platform that we're dealing with, which you might think is spaghetti. I'm going to show you some examples of that in a second to prove that wrong. And the components are fluid, so a component is always written to fit the boundaries it's put inside of, but spatially a component would never actually have sizing on itself. When you start following these rules, you're going to find it actually lets you write some incredibly declarative cross-platform Ember, or in any case. And this is where Flexi really starts to come in as well. Again, Chris wrote Flexi, not me. I'm just the guy who gets to promo it today. But what we do is we go back to that pod that we had before, and instead of having templates.hbs, we add a layouts folder. And in layouts, we add desktop, mobile, and tablet. So all of a sudden, we can start to write a completely different template for each platform, only in the cases that it matters. We can still use templates for the generic cases where it's not going to change. We can still use templates in the cases where we might only need a single Boolean and it's kind of excessive. We can actually start to reason about our layouts differently. Most importantly, as a developer, I actually know the ramifications of my changes now. If I need to go and make a single change to the mobile implementation of something, it's actually very easy to go into the code and trace what's going on and what I'm supposed to do. So going back to our earlier example, we have desktop.hbs now, which just renders everything that would have been in desktop. We don't have any complex booleans, we don't have any complex classes, we're just putting exactly what belongs there. Likewise, for mobile, we're doing the same thing. That display none shouldn't be there. I think I just copy-pasted the wrong screenshot in. But imagine that was actually displaying, otherwise that would be a pretty shitty mobile layout. But what we've just done here is we've already ditched reflow and reorder patterns. All right, we no longer have all of these things sitting in the tree that aren't being used because we've declaratively rendered the right template, and we don't have to go and resize every time somebody changes the screen. An important thing about Flexi as well, though, is that it will handle the case where you've passed a breakpoint, you need to start changing your desktop or start rendering your desktop layout, sorry. But that's one expensive operation that you pay once, and realistically, that doesn't happen as often as people think. Somebody's accessing on a mobile phone, they're not going to render the desktop layout by resizing the app. Somebody's rendering it in Chrome, they're not going to render the mobile unless they make the browser this skinny, at which point, you know what, you deserve like a half second of lag because you're the edge case user and nobody cares about you. But what we have here is already something that's much easier to follow in my mind. So the next thing we start to think about is, well, if we have these much easier to handle templates based on whether we're building for a tablet, a phone, or a desktop, what else can we do to make our jobs as developers or front-end developers even easier? So the next thing Flexi has actually introduced is different types of elements. So instead of using a div, you can actually use these. If you're sitting there thinking, this doesn't sound right, this isn't actually a legitimate element, there's actually an unknown element spec. So you can actually put whatever elements you want in HTML. I wouldn't encourage just making them up for the fun of it. But every modern browser will respond to these completely fine. And the worst you'll do is you'll throw a linter error, which just means you need to go and tell your linter that these are legitimate elements that you're using. At runtime, Flexi actually does go and change these over to classes for you, so it does just enable much cleaner template writing. But the first element we have is a screen. And a screen element is always guaranteed to take 100% of the width and a minimum of 100% of the height. So we don't need to go and worry about all of these different classes we typically write. We write, div outer container, height 100%, width 100%, and hope to dear God that it works. We then have a page, and a page is always just statically set as the size of the screen. It will never be bigger, it will never be smaller. So if you need to lock something to a single window, you'd start using a page. We also have fill elements, and fill elements are just going to fill whatever it is that you put inside of them. So again, you don't need to go and start worrying about width 100%, height 100%, and making sure every parent also has these set so they'll actually work. You just type in fill, and this is going to be handled for you. We have box as well, and box is an important one because a box will grow to the size of all of its relative boxes, but not to the size of its container. So if you need to render 4 columns next to each other, all of which are the same height, but height is set based on which one is biggest, which you can't possibly know when you're programming the thing, you can go and implement box, and it will make sure spatially all of that's done and handled for you. And last here we have hbox and vbox that is very much the same, but it will actually go and fill the container one or two ways. So if you need a box, it's going to stretch all the way down to the bottom of the screen, for example. So going back to our earlier template that looked a little bit like this, I'm about to explode it in terms of elements here. But we can start reasoning about it like this. I realize it looks like I've added some more code here, but I've obviously included the containers, which I didn't have in the contrived examples before. But all of a sudden, I think this is much easier to reason about what we're trying to do. We have a screen. On that screen, we have a page, which is just set to the size of what we're trying to do. This is the desktop implementation, by the way. We then have a box for nav. Then we have hbox, which again is going to expand to fit the rest of the page. And inside of that, we have 2 different boxes, one for that contact list and one for that contact resource. So all of a sudden, as a developer, I can go in and actually see what the intended layout of this app was. I haven't even had to go and look at any CSS rules yet. And it's not that you shouldn't need to all the time, but to have a general understanding of what grid's going on, it's kind of ridiculous, and that's what we're trying to solve here. Another interesting point as well is we have this tool in Flexi called sustain. And what sustain does, imagine the inverse case here where somebody's actually resizing the window, and we do want to trigger a layout change, right? Maybe we want to take them down to an iPad-style layout. But again, we know our nav's going to be the same component, and we know that our contacts list is going to be the same component. So you can actually implement with this command called sustain. Again, if you're in Angular, there's probably something similar there for you. If you're in React, hopefully there's something similar for you as well. But sustain will actually make sure that that element is completely recycled among the new template. So instead of having to deal with completely deleting and recreating something that's the same, it's actually just going to pull that off and put it back in. This is also incredibly handy when you're doing route transitions, but you're rendering the same component on 2 different routes or 3 different routes back to back. If you use sustain, you're guaranteed to not need to go through that reallocation process over and over again. So a couple of points of further optimization. So, in guaranteed mobile-only environments, try not to download the desktop assets if you can help it. This is, again, something that you might want to start handling through a Flexi or whatever framework you're dealing with, that in mobile, actually tag your mobile-specific assets in that template. And in your desktop, tag your specific assets there. I think partial to this as well, and we were laughing about this earlier, a lot of people just don't resize their images for platforms and start needing to download 5 megabytes or 7 megabytes of just straight up images, which on something like this, it doesn't make a difference if they're 200 kilobytes or a megabyte, right? It doesn't matter. Another little thing here as well is use fingerprinting. If you're not familiar with what fingerprinting is, it just generates this big long string at the end of every asset name, and it will regenerate a different string if it's changed. And what that means is that when the browser goes and requests it, it might know that it's already seen that resource before, but it has the capability to know if that's changed. It's just a way of handling caching, right? The more we don't need to go and re-request the same assets, the easier it is to actually start rendering these things fast and performant. So in a quick summary before I go to questions, really what I've tried to take you through is just a high level of how is it that we reason about these cross-platform designs, but then when we start to look at media queries, how can we start to approach that in a different way that's more declarative for programmers, but also allows us to write things in the most performant way? And our belief in approaching these things is instead of sitting there trying to monkey around with media queries all day and figure out how to make it layout work in 3 different scenarios that are actually kind of different, let's just take the extra 20 minutes and write 3 separate layouts that go and implement the same components over and over, make them as declarative as possible, and always trust that our components will fit whatever space they're put inside of. And sometimes, yes, that means that you need to go and put a container around a component to guarantee its size. That means the poor developer who you've asked to go in and make a single change to a single component doesn't need to worry about accidentally adding 20 pixels of padding to the thing, which destroys the rest of your layout. And you'll find this pattern really starts to work when you're putting 5, now 7, now 15 engineers on a single front-end project, and you need us to all be able to work together without stepping on each other's toes or completely breaking the thing in the process. Well, I thought I had a summary slide there, but I don't. So that's the end of the prepared content I have, but I usually try and leave a bunch of time at the end for questions. So any questions? Yep.
Any plans to include TypeScript in Flexi?
So TypeScript's vaguely being used in Ember already. It's one of those things where there's no point in dealing with the implementation of that when other people are already working on it, would be the right way to put it. I'm actually a big fan of using TypeScript, and I don't get to use it as much as I would like. So, yes. Well, thank you very much. Oh, there is somebody?
The Flexi script that you use,
Yep.
where did you source that out?
So it was actually written by Chris at ISLE. I will go back to the screen with the link for you. But it's a completely in-house project. It's open source, so anybody's able to use it. Everything I've mentioned today is completely open source. Where are we? But if you just go to GitHub, you'll find it there. Do whatever you want with it. If you use Angular, feel free to port the thing to Angular. Alrighty, thank you very much.